the goal for today is to start putting together all the pieces from the front end and the back end of our application. Okay, so right now we know how to say implement an API server. We know how to implement a React application that works on its own, but we try to see what is needed to put them together so that the client can use the API, can exploit the data and the services provided by the API. So what I did, and will be the work of this week and next one, is trying to put together, in week 9, you see on the GitHub, I just copied over the client application that we had from last week, so the one where we play with the routes and so on. And I went back in time and took the server version coming from week number 5. Remember when you were adding the authentication to the API calls, okay? And well, I just copied them here, and now they're just sitting there one beside the other, and we're trying to make them work together, okay? So actually, what's in the menu, what's in the table? First, we need to know how a React application may call an API. Up to now, the only way of calling the API was to write the call in the HTTP file and try it by hand to see how the call went through. And today we'll learn about the fetch API. So a fetch is a function in the JavaScript standard library, so has nothing to do with React, but it's implemented, of course, in the standard JavaScript library, which is used for making HTTP calls. Okay, but before, and so that it will be the glue that puts together the client and the server. But before that, we must understand how and when to call this API, this fetch function actually, inside the React application. Because React is a controlled environment, it's a controlled system where we cannot just do whatever you want and when you want. Okay, so we have to spend some minutes in seeing how to extend the life cycle of React components. Because right now we have a simple view of how a React component works. Okay, when some prop changes, when some state changes, then the component is re-rendered. That's it. Okay, so we are now, up to now, we focused mainly on the rendering steps of the component itself. Okay, plus some event management. So we have the on-click or some other event that let us basically change some state variable according to some user action. And then is the state variable that was triggering another rendering. Okay, so most of the focus is when do I need to render, when prop changes or state changes. Actually, of course, it's a bit more complex. There's something under the hood that may happen after the rendering, and we are not now. And sorry, last point. The render phase, everything the render phase must be. This was one of our rules. Totally functional. So every component with the same props and with the same state must always render in the same way. Should be a totally deterministic function that will generate the same identical output every time it's called, unless, of course, the parameters are changed. Okay, that has to change because, of course, if you have a list of messages and I am refreshing this list of messages, the content may change because the messages themselves may have changed in the backend, of course, in a database that are connected. So we need to do a step further than this simple model, which is very nice, but it's only for static data, basically. This picture shows us the life of the React component in general. So a component is an object. No? An object is created and destroyed. We saw that when we were playing with the forms, you remember that we are opening and closing the form, and every time we open it, it's initialized from scratch. Remember when we played with the edit functionality, we saw that some states were initialized again or not, depending how. So actually, the lifecycle of a component is very simple. The first time I render a component, the object is created, and React calls it the mounting of the component itself. Once the component is alive, it can receive many updates in its properties and its state variables, and at every update, update of the inputs will re-render itself. So as long as the component is alive, can be updated many times. It means that the render part of the component is executed many times. And finally, there could be one step where the component is unmounted. What does it mean? That the next render of the application, that specific component is not rendered anymore. There will be an if somewhere that say, or the route that specifies that that component is not anymore part of render tree. And in that case, the corresponding object is destroyed. And it's never reused. So if you happen to have a page with a component, do something where this component is not rendered anymore. And in the next step, you render it again, it will be a new component, a new instance of the same component. So it will be reinitialized from scratch. If you are not showing one component in having even single step, you are destroying the object and recreating it. Okay? And of course, there's all the work that React does to understand whether in the next render the component tree has changed or not, and that's why the reason we need to put the key attribute when we are rendering links of identical components, so that React can understand whether I'm rendering the same three components or three different ones. So the first three should be destroyed and new ones will be created. So it's all internal to matching what you actually see on the page with the component instances that we have in the virtual DOM. Now, so there are these different time points where the most important, of course, is the updating. If we break down what happens in these three lifetime moments, mounting, updating, and unmounting, the three columns, we see that every time a component is called, and it goes through two different phases. One is called the render phase, and the other is called the commit phase. The render phase is what we know best, okay, where the function is called and returns some component tree. This is the functional part, the purely functional part. The first time the function is called, the component is created, the state is initialized, and all the hooks are initialized for the first time. The render may happen many times during the updates, so we can call and use the states and context variables and so on, like we did today. So it's just re-rendering because some data has changed. That's the easy part. But so this happens inside the library. The functions are called, the component tree is created, is converted to the DOM, and then displayed in the browser. Once it is in the browser, the page reacts and sort of loses control over the page, because now the page is displayed in the browser itself. The DOM is updated, the real DOM in the browser is updated, and so the browser does its work. Some component may be uncontrolled, like we did with forms, and so the DOM may also evolve due to the user actions. And sorry, what's the picture? During the render phase, where we said we always must be functional, so everything we do must be totally repeatable. in our jargon, we say that a functional component must never have a side effect. Side effects meaning it can never modify anything outside its own return value. And it also can never rely on some other information that comes from the outside of the component itself. So for any information that is not in the props and is not in the state or in the context. Okay? So this is the rule for the render phase. But what happens if we need to have some side effect? If a component actually needs to change some information outside itself or to receive some information from the outside. This cannot be done in the render phase. It can be done in the second phase, which is the commit one. Okay? So we already know something that may happen in the commit phase. So that, for example, when the event handlers run, on click is an action that happens in the DOM. Once the DOM is created, the user does something, and it calls a callback function that will change the state or does something. Okay, this is a controlled way of working with the DOM events. It's controlled because actually an event handler cannot directly change the DOM or interact with something outside the component because it can only affect the state, and affecting the state will cause a new render, of course. These are easy, so event handlers are easy because they are, let me call them synchronous. They are not really synchronous because when I click, then the event handler is scheduled to be run asynchronous and so on. But we know that we have to do something when a very specific action happens. And this action happens in the DOM, in the browser. Okay, so we can handle it immediately. But there may be other cases when we want actually for a component to reach outside. The main goal is, for example, fetching the data it needs. So in our example, the list of questions which should come from the server, from calling the API server. So for a component to be able to show this data, the state variable must be initialized by reading some information from outside the component itself. It cannot come from the application, from the React application itself. At a given point, at a given level of the component tree, some of the component must go outside, call an API, and get the result. This is an operation that breaks the boundary of React components. This is the main goal. Or the same is for sending data. When I adding a new answer in our application, I need to store it in the server. So in that case, we'll change the data outside the application itself. Plus, if I want to do something with a timeout, with a timer, that also means an animation maybe. Something that appears and then after 2 seconds goes away, or something that is, we have a progress bar that goes through, and so it will change the render of let's make a simple example. The rendering of a progress bar is something that depends on time. In 3 seconds, it should go from 0 to 100. Time is an external variable. It's not a prop. It's not a state. Okay? So the component should re-render according to some external value, something that happens outside the components. And we should be able to use them. We cannot just use a property progress bar value with a given state variable and hope that this state variable will increase automatically. We should have a mechanism for catching external events, maybe with a timeout or an interval timer. So, okay, every second, every 10th of a second, 0.1 seconds, update the state variable, and then we'll trigger a render, and the progress bar will go forward one step. But we need to link the update to something that happens outside. It's not just a click of the user that comes from the DOM. It's something that happens totally asynchronously due to an external factor, a timer, time passes, or a network call is started, or a network call, an API call, is finished, and so on. Okay, so there's a lot of side effects. This is not a bad word, side effect. It's just something that we cannot do in the functional word. We cannot do it during the render phase, and we can do that in the commit phase. So today we start to learn how to work in the second phase. When the page is already rendered, so we cannot affect the rendering itself. Okay, what is being shown right now is already there. After it's rendered, we can, be sensitive to some external event that happen, or do some actions that will happen afterwards. Of course, what we do in the commit phase may change some state variable, and so start a new cycle of updating. Okay, so the new render will change something, but we are not able to change it directly. So the rendering and the side effects should be are executed in two different moments, and side effects, since the body of a function, of a component function, is actually the render phase, all the side effects, let's say, no side effect may happen in the body of the function itself. We should in some way find a method for scheduling side effects to be run not during the render phase, but during the commit phase. Okay, so during the render phase, we are scheduling something that should happen afterwards, after the commit is completed. If you remember last week, I made a mistake. I tried to call the navigate function from inside the function body, and React slapped me in the hand and said, you cannot do that here, okay? Because I was trying to do something with a side effect, changing the URL, inside the body of the component that can only do rendering, so can only affect the component tree, not anything else. Okay. So today we are going to the mechanism for declaring places where side effects can run. What they should run, what we should do, and when we should do it. What are the causes that may trigger this kind of side effects? And all of this is managed by a hook which is called useEffect. So it's a short name for use side effect. They only call this useEffect. And so this hook is very rich, I would say. There's just one hook, but with a lot of functionality in it. Okay. So it can be used in many different ways. And it can be abused in many more ways. Okay, so if you see the documentation in React, there is a section synchronizing with effects that will explain us how the effects work, and we see that today. But there's also a section called you might not need an effect. Okay, so there are many, and we'll discuss this, there are many things that on the first site say, okay, I need to create a use effect for managing this information or this action, for updating this state variable and so on, and where actually is not needed because it will be just managed by a proper usage of initialization or state variables or the normal rendering mechanism. Okay, so once we understand the use effect hook, you will have a phase where you want to use use effects everywhere. Well, actually, in many cases, no, in some cases are really needed, but in other cases can be, well, they would be the wrong implementation to a solution. And also be careful, because there are many information online which is also picked up by the AI tools that gives you examples where the solution is much more complicated than it needs to be, because they tend to put a useEffect, and then it's not enough. They ask you to put a use memo or a use ref, a very complex solution where actually it was something that should be designed in a different way. But we'll come to that. Okay, so we'll learn how to use effects and also how to not use them by relying on what we already are able to do. So let's become friends with useEffect. Actually, there's something that we already did which technically is wrong. Okay. Actually, when we have a console.log into a component, logging into the console technically is a side effect, because it's affecting some information outside the component. It goes to the console. Okay, we didn't care, and React didn't complain about that, but actually they're very simple example of something that, some information that goes outside and should be, you know, wrapped inside a side effect. Say, okay, this operation that you want to do right now must happen, or will, I know that it will affect something outside the component itself, so it should be wrapped into useEffect. So basically, the useEffect hook can be just seen as a function that contains a callback, and when this callback is run, it can do whatever it wants, including side effects, because it will be run in a moment where all the render tree is stable. So it cannot affect or modify or you know, be. Why should the render tree be stable? Because we never know the order in which the render tree will be constructed. So we never know during the render phase which part of the interface will be rendered first or later. So actually, we would introduce, if some component looks outside itself, it would introduce a non-deterministic behavior. I'm looking to another component, I don't know whether it still has to be rendered or already rendered before me. So first we render everything, and then when the DOM is stable, we do additional stuff. And this is useEffect just for scheduling this additional stuff. So useEffect is a hook that receives two arguments, basically. The first argument is a callback that executes the side effect logic, the logic that contains side effect. So the actual function that we want to run in the commit phase. So the first argument is a callback function, and the second argument is an array of dependencies. So the first is what do I want to execute, and the second is when should it be executed. Dependencies is a set of variables that are monitored by React, and when one of these dependencies change for some reason, they may be props, they may be state variables. When some of them changes, the effect is run again. The function is run again. So this function will be run, may be run, sorry, every time at least one of these dependencies are changed. I said may be run because there may be some changes that are skipped. If two or three dependencies change at the same time, the function is called only once. So actually, React also tries to collapse the calls to the function, to the callback function. This dependencies array can be interpreted in three different ways. Now, there are three different ways of constructing the dependency array. The first one is undefined. So we don't define a dependency array. This means that at every render, the side effect runs. So every time the component is rendered, we run the function, the callback function. And every time it's rendered for any reason, the prot change, the component is remounted, the state changes, or whatever. Okay? This is very similar to what we had here in this console.load. This console.load is executed every time the component is run. The function is called. The component is rendered. Okay? The difference is that we are executing that in the body of the function, and with a useEffect, we would just delay the execution after the render phase. A second option is to list an empty array of dependencies. And it's totally different, because in this case the effect is run only once, which is only when the component is mounted, not when the component is updated. Okay, so if we want to run some code only when the component is mounted for the first time, we should define the callback and put an empty array as a second argument. In that case, that callback will only be called once, and for all the updates of the component will never be run again, until the component is unmounted and maybe remounted again. At that point, at the remounting, it will be a new component. Of course, it will be the first time for it, and the callback will be called. Okay, so there are two extremes. I call it only once at mount time, and the other extreme, I call it at mount time plus at every render. In the middle, we have a dependency array that actually lists some properties or some state variables. Normally, you can list any kind of variables, but the one that counts usually are props or states. And in this case, the side effect runs after the initial render, always. So when the component renders at the beginning, all the effects are always run. Whether you have you skip the dependency array, whether you have an empty dependency array, whether you have a dependency array with some values, at the first render, effects are always run, no matter what. Plus, these effects can also be run when at least one of the dependencies are changed. Change with respect to the previous rendering, of course. Okay? So in this case, you can select, okay, I need to update, I don't know, the error messages only when the data on some form element has changed. Okay? And not on every render of the component, only on some renders when some specific value has changed. And very likely, those state variables will be used inside the function to change something, to do something. Okay, normally it's not very useful to run a callback when some variable changes and inside the callback the value of the variable is not used. Because what are you doing? Why do you need to run this function if you don't depend? So normally, where we see when we write some code, we do the other way around. We decide what we need to run, and we have a look at the variables that we are using inside this callback and say, okay, which of these variables should be in the dependency array? Okay? Because if the variables don't change, we don't need to run it. But if there are changes in the variables, then the code will be run again because some variable is changed. Okay, these are just some examples. useEffect, callback, and no second argument runs at every render. Very seldom used. There are not many examples in which we actually want to run something after every rendering, also because we don't have any control over when a component is rendered. So it would be just running many times the same component, same function. The empty array can be used for initializing the component, and we are going to use it a lot for fetching initial data. When I render the component with a list of answers, okay, that component, when initialized, goes to the server, gets the list of answers, and populates the component itself. And then it doesn't need to do it at every render, or no. because once the list is ready, it can be rendered and it can be stored in a state variable, and it's just at the beginning that we need to go and check. At the beginning, or maybe when something changes. When I delete something, when I add something, I need to refresh it sometimes. And the other case is, of course, when we set some properties, and it runs once at the initial rendering and after every time one of these properties or states has changed. Okay, this is just some. You see that these three codes are very, very similar. So we should, especially the first two, whether we don't have the second argument or we have it as an empty array. So we should always be careful not to confuse the two, because they are actually implementing totally opposite behaviors. Okay. This is an example of how they work. It's a synthetic example where we just tell us the difference between having the empty array or a dependency array. You see that we are defining two effects inside a component, and the callback is the same. I'm logging the value of a property. So the callback is identical, and we have somewhere a button that is incrementing a number, I, set number, and this number is given as a property to this component count. So count contains a property called props.number, which I'm printing here and there. Okay, and a button that when it's outside this component, it may increment this counter and so change the property of the component itself. Okay, so what you see when you run this is that the first effect is only run once with the initial value of the number, and then the second effect is run at the beginning. So at the beginning, the rule is always all effects are run, both the initializing effects and the update effects. So at the first run, the first two prints are executed. And afterwards, only the second one is run again, when every time the number property is incremented. And the first one is not run at all. And this is easy because we only have one variable. So inside these callbacks, we only have one variable. So actually, in the first case, we are seeing the initial value of that variable. And in the second case, we are seeing the latest value of that variable. Okay, so there's no confusion. When we have two or more variables, it can become confusing, because maybe one variable will trigger the execution of the callback, and then the callback will use a second variable inside. And so there may be cases where the second variable, if it's not in the dependency array, may change without triggering the callback, and so may run with an old value instead of the latest one. So there are some corner cases that may happen, strange bugs that may happen if the dependency array doesn't contain all the variables that are used inside the function. So actually, this function uses this property, and it tells me that probably whenever this property changes, the function should be executed again. And so the rule that we are learning is in the dependency array, if you are putting one value in the dependency array, put all of them. All of the variables, all the props, all the states that are used inside the callback itself. So it becomes predictable. What can you do in an effect callback? But whatever you want, including changing a state. So you can call inside the useEffect function, not just console.log, but you can use a set state for something else. So actually, the interaction between states and effects is two-way interaction. Effects may depend on state variables. In the dependency array, I can have some state variables. When the state variable changes, the effect is run. One way, a state change can trigger an effect callback. The other way around is inside the useEffect callback, I can call a state change function, a set number, set user, set answer, whatever. That will change a state variable, or it will schedule the change of a state variable. And the state variable itself, of course, the change of the state variable itself will trigger the rendering of the component that depends on the state variable. Okay. It may also mean that the effect or some other effect that depends on that state variable will run. Okay, so let's have a look at this code here. We have a component called QuickGate that renders what? Renders just a text. Okay, it is called go or stop. Okay, and it depends on the variable, on the value of a variable called open, which is a state variable instead of the component. So open defaults to false. So at the beginning, the gate is closed, stop, because open will be false at the beginning. And it will state close, stop, until the open variable is still false. Okay. useEffect. Then we have useEffect, and then we have a callback here, openMe. OpenMe is the event handler of the click over this text. So it just sits there, and it will only be called, or we call every time the user clicks on that string. But the useEffect has a life of its own. So what we know is that we have a useEffect with a dependency array containing one state variable, open. Okay. So this effect is run at component mount time and every time the open is updated, which is a bit buggy in this implementation, but just to understand how it works. So the idea here is that when the user clicks on the gate, on the button here, on the text here, openMe will set the state to true. That's normal, nothing new. So I click on the button, openMe makes a set open true, and will schedule a change of the state variable open. This will trigger a render of the component, and the body of the component will now show go instead of stop. So we open the gate. At the same time, the change in open triggers the execution of the effect callback. And what does this callback do? It sets a timeout that after 500 milliseconds after the effect is run, and the effect is run after the state is changed, and the state is changed after the button is clicked. So immediately, half a second after we click on the button, the timeout will expire, and we call set open to false. So actually, when we click on the gate, we can say stop. It will become go for 500 milliseconds, and then we'll close again. So one direct action of a user, a normal event handler, has scheduled something, a side effect that will happen later. And then we change the state of the component to close the gate again after half a second, and render it from scratch. Okay, that's the intended behavior, and more or less works like this. Okay, so in this case we are observing some action, and according to something that is happening now, we are scheduling something to happen later on. This is also a behavior like, when you have an error message shown and then it will disappear after a given time by itself. Okay, you are triggering a timer with an effect that will run and will disable the visibility of that component, for example. I said that there's something more happening here, that is, maybe we wanted it or not, because this timeout, in my description, the idea is that the timeout is scheduled, so the callback is run, and so the timeout is scheduled when I click on the button and when the open variable switches from false to true. Actually, this callback is called other 2 times. First, at the component render, at the component, mounting time, at the first render. Every effect always runs at least once at the beginning, always. So even in the default state, when nobody touches anything, when the component quick gate is rendered, this effect is run, this callback is run, and so we are setting a timeout. We are setting a timeout that 500 milliseconds after the component is mounted, is shown for the first time, it will close the gate. So you see, okay, that's invisible, because the gate was already closed, right? Because I'm setting to false where the default value was already false. So that's true if nobody touches the button in the first 500 milliseconds. Right? So I initialize it to false. In half a second, it will be set to false again. Nothing happens. But if the user, after 250 milliseconds, clicks on the button, so I show it and very quick to click it, it will, of course, trigger the timeout. So I'm clicking on it at time 250. I'm triggering the timeout for closing it at 750. Okay, 250 plus 500. But there was already a timeout from time 0 that was triggered at time 0 at the component mounting time that should close the gate at 500. So there's a small window in which when the user clicks from, for example, at time 250 milliseconds, the gate will be closed at 500. Not at 750, because it's the timeout that we set to the component mount time. Is it a problem? I don't know, it depends, of course, but we should be aware of that. Okay? So not only the effect runs when the variable changes in the way we like it, but also at mounting time. Can we prevent it? Yes, maybe. We have to do an extra check saying, okay, maybe if the gate is already closed, don't schedule any timeout for closing it. And so there was one unintended call that may create strange behaviors in the application if we don't remember it. And the second is that the effect is run every time this variable changes, independently of the direction in which it's changing. So it's we are scheduling the timeout every time the gate is opened, but also every time the gate is closed. Every time open goes from true to false, we are scheduling the effect again. So you see, simple case. The component is there, so the initial 500 milliseconds already are gone. Okay, the user clicks on the button, which now reads stop. Clicks on the open me function is called, set open true. After very little, the state variable open becomes true. This component is re-rendered. First rendering, then side effects. So first the component is re-rendering, now it displays go, and then the callback realizes that open just went from false to true, and so the callback must be run. And this timeout is scheduled. Fine. And everything is stable. After 500 milliseconds, the timeout expires, and so the callback of the timeout is run. Set open to false. Fine. The state is updated. The component is re-rendered, so the gate is closed again. But the effect realizes that the variable open just went from true to false. And so it must run the callback again. So the callback, of course, will execute, and will set another timeout that in 500 milliseconds will close again the gate that is already closed. Right? So we are scheduling the action close the gate whenever the gate is just opened by the action of the user, but also when the gate is closed by the effect itself. So this is not very nice, because the same argument is valid also in the second case that we had at the beginning. So there's an extra timeout with just a closing action which is unnecessary, but it will get in the way if the user is trying to open the gate just immediately shortly after it has been just closed. Okay, let's put some number. The user clicks here at time 1000. The gate is closed at 1500, so 1500 it will be closed. But then at time 2000, there will be another closing action being scheduled. And if at time 1900, so 1900, the user will open the gate again, the closure will be scheduled for 2400, but actually we close at 2000 as a consequence of the scheduled closure that was scheduled at time 1500. Why is that? Because we are unconditionally running the callback, and in sometimes we should want probably to have more control of that. So all these problems can be solved just by putting an extra if here, saying, okay, in effect, if open is true, then set the timeout. Otherwise, don't do anything. That will solve both issues. Okay, so this timeout for closing, it's only if the current state is okay, it has been open, so I need to schedule the closure. But also we always should ask ourselves when we have an effect, okay, what do I need to do at the first run, the component mount time, and what I want to do when the state changes in a direction which is not what I need. Okay, so that's the general rules that we must be aware of. Okay, for doing something useful, yes?
So can we be sure that the initializing of the state variables like open will happen before the first call of the user thing?
Yes, yes. The initialization state is always before, because actually the time, the effects are run after the render phase. So we first set the states, we update states and props, do the render, and after that, with the already initialized value of states, and then run the effects. Yes, so we are always sure. You can also mix them in the order you want, but the effect will always run last. Okay. Okay. So for doing something useful, we have now a tool, a place with some warnings actually to where to write some side effect code. And the most important side effect code that we want is to be able to interact with the server. I call an API. So using fetch, the fetch function. So that I mentioned before. So what is this fetch function? It's actually quite easy. Fetch is a function in the JavaScript standard library that activates a call to an HTTP. So it implements an HTTP client. So fetch is useful for making HTTP calls. So every time the client application needs to interact with the server, it needs to do an HTTP call for calling the API. And this HTTP call is created and managed by this fetch API, fetch function, which is very simple because actually it has one argument, which is it's a promise-based interface, so quite easy to use. And it gets one argument that is the URL that you want to call, and it returns a promise with the HTTP response coming from the remote server. So I'm calling get this address, and when, okay, the left-hand side of this picture just shows the then syntax for handling the response coming from fetch. Maybe it's easier to read the right-hand version, where we are using await. So we are calling fetch on a URL. It will create a get HTTP call and return a promise. This promise will be fulfilled when the answer comes from the server. At that point, we have the response object, and this response object will contain the result, so the status and the body of the response and so on. That can be extracted, of course, always with asynchronous operations because we need to schedule them when they happen. Okay, so making a remote call from our component is just as easy as making a fetch call. And it returns a promise that contains a response object, and this response contains two attributes that describe the status of the operation. So the first one is OK, yes or no, true or false, depending on whether the status code was in the range of 200. Or actually, you get the status code, which is the actual number, maybe 200, 500, 400, and we can parse that. So it's just a shortcut. OK is just a shortcut for checking whether the status is included between 200 and 299. We have all the headers, the URL, and especially the body that contains actually the response body. So remember, in Express, we have the result response.send or response.json that was constructing a response object and sending it back through the HTTP channel. And we are getting this value and extracting that into a response object in the client at this point. And this is for get calls. Well, we can't elaborate later on. So this for a get call is very simple. I give you the URL and you tell me the response that I can then extract. But what happens if I want to send a post or a put call with a different method? Okay, it's easy, also easy because the fetch allows a second argument, which is an object with a lot of properties, and one of these properties is of course method. And also body or headers. So I can, before calling fetch, I can build an object, which is the second argument of fetch, with all the specification of the call that we want to make. The method is post, and the body is encoded in a JSON format, and it has this content and so on. Then we can call fetch, and if you have a second argument, the default will not be issuing a get or issuing some kind of, for example, here in this kind of fetch, we are sending a post call to a given URL. So the URL is whatever the API URL is, and the second argument is an object that contains a method and the body. the method should be a post, the body should be an object to send in JSON format. And of course, when I'm sending something in JSON format, I need the server to know that the payload, that the body is in JSON format, so that the server can decode JSON and construct the object itself. Remember, in Express, we had a middleware for extracting the JSON from the body. And for telling them, we also had to do that by hand, writing content type is application JSON, and we can do it also here in the fetch. So fetch allows us to execute from our JavaScript code the same kind of API calls that we were right now just writing by hand in our test.http file. Okay? Sending the call is easy, just the URL and the other information. Receiving the result is also easy because we have a promise that returns a response object back. The other point is that this response is just an object. For getting the actual headers or the actual body, we should call extra methods on the response. They are also promises, of course, because a method called on a promise is a promise itself, must be a thing itself. And basically, we are going to call .text or most likely .json, because the response will be most likely returned in JSON format. And so JSON will wait for the body to arrive and parse the JSON, build an object, and return me the object. Return me a promise that will resolve to the object. Okay? Okay, so we'll go back here when we go to error handling and so on, but just to show, okay, how it works. So let's try to put this together. We have the client of last time. We have the server, which is still running. And so let's try to make a component that will load some data from the server from the first time. There's still a couple of steps that we need to go through, but let's see them in the code. Okay? So what I'm doing here is now trying to run simultaneously with the server and the client. So usually I split the terminal in two, and where am I? I run the server, adjust my habit, on the right hand side of the terminal, and the client in the, okay. So that just to check, in Nodemon. Okay, so I'm running the server, you may remember from 5 weeks ago. Okay, we had a server running, an API server, and on the other window I'm running the React application. Okay, so right now there are two servers running on my computer. One is on port 3001, which is the API server. The other is on port byte 5173, which is the client. And this client is exactly the same that we had last week. Okay, the login and the question and so on. Okay, I didn't modify it in any way. But they don't talk, no? Right now. And for the server, remember that we had some tests just to check. We have the API questions. If I send a request, I get some list of questions. Okay? And the API is called. Right now we are just calling it from here, from the test file. We should always be careful right now, because we are going to see and modify files on both sides of the ocean. Okay, some files are on the server, some are on the client. They are in totally different worlds. They don't share anything, any variable, any information. Okay, so always be clear in your mind what kind of files are you opening. Okay, if you have a computer with two screens, maybe put the client in one screen and the server in the other, just to help yourself. Okay, have your mind making the split. Okay, so what the easiest thing that we could do is to change this page, the list of questions. Okay. It's a simple component. We are in the client. We have app that says, you see, /home from last week. /home renders home view with a list of questions. Okay? It's with an array of questions. Home view. The component home view right now receives the questions from is a property and will render them. So what we want to do right now is this home view actually doesn't need to be changed, but the app component, which are always here, should load the list of questions from the database instead of what did I do? Of having some fake question. We are doing that in app, then every single component can do it downstairs, down in the different component tree. So actually, what I would like to do is to actually write somewhere some code that looks like set questions. Well, it is not real code, okay? It's just my wishes. Set questions to fetch the data that comes from, sorry, in the server we had the test HTTP from here. Okay, conceptually this is what I need to do. Okay, I say, okay, when I initialize the app.js, let's do a fetch on this API, get the result, and use it to initialize a state with the list of questions. Okay? Okay, we cannot do it here for a set of reasons, which is too long to list. First of all, we cannot call fetch inside the render tree. And second, fetch returns a promise that we need to wait for the response and so on. Okay? But the idea is how to do this. So first of all, we have this is a side effect, and so it might be wrapped into a use effect, and we decide when to run it. Okay, so when do we need to run this? Well, at the application, at the start of the application, at the beginning of the application. So it could be a use effect that would run a callback only at the beginning of the application. So at the beginning, and the component mount time means, sorry, let me make it a bit larger. And so it will become, okay? We don't have any dependency. We run it once, and that's it. Okay, we know that we should run it again when you update the list of questions. But okay, that's something that we can refresh it. But there's no reason that other state changes could trigger the rereading the application again, the list of questions again. Okay, so here we have, let me write a comment, read the list of questions, the full list of questions at application startup, which means when app mounts. Application startup is a concept we have in mind. Actually, physically, is the app component, which is mounted for the first time. And so it runs this effect. And what should we do? Oh, we should actually go and fetch this data. So we should actually say that we have the response. Could be this one. And then when the response comes, I extract the list of questions, from JSON. And finally, with this list of questions, I can set the state, set questions. Okay? So this idea is a bit more detailed here. Of course, we don't have a state called questions, plural, right now, because in our fake implementation, we just had room for one question. But that's easy, okay? Let's define another state, and this should go away. All the fake states will go away. But for the moment, we define a state for the set of questions that will be initialized with an empty list. Okay? And this list of questions is what we can give to our, let's go back to the render. You remember that we had to provide to the component home view a fake list of questions by creating a single array with the only fake question that we had. Okay, all of this is in the past, because right now we have a state questions with a real list of questions. Okay? So the issue is that we need to load it from the server. So let's go back to the effect. useEffect is, okay, there's an issue here because we didn't import useEffect, so let's go up to import also the useEffect from React. And we should be aware that, okay, this fetch is actually a promise. Okay, so actually we cannot write code like this. We should either use the then syntax or an await statement. Let me write it with then now, because for using await there's also another issue that we have to solve, because the callback should not be asynchronous. I will come to that later. So for the moment, just think about fetch returns a promise. Let's assume it doesn't return any errors or whatever, and it just runs. Okay? So instead of writing like this, we should write in the then response callback. Okay? So instead of writing like that, we just issue the fetch and then manage the response. And right now, the response will be a response object from which we can extract the body. So we can do the same here. Response.json that returns a promise. And when the promise is returned, we will have a list of questions. And then at this point, we can set questions to this list. So the same logic, but wrapped inside the then chain. of asynchronous program. This is the first and the last time I will write fetch inside a component, okay? We are mixing level of programming in a bad way. So after the break, we'll create maybe another file called api.js where we put all the API calls, and here in useEffect we'll call the function with a nice name and nice error handling and everything, okay? But right now, just to see what is happening, and then we break it down in a more architecturally valid possibility. Okay, so this looks like, I don't know if I had any errors in the code. There's an, okay, there's just some missing variables. So if I save this, so right now we are running this effect. This effect is hopefully calling the API server and is populating this list of question state, and this list of question is, right now we are only using it in the home component, in the home route that we rendered it. So let's try to see it, if it runs. Of course it doesn't. For a stupid reason. So actually we executed this fetch. We did execute it, and it created an error here. Access to fetch this API question has been blocked by course policy. So when we tried, I just told you, okay, fetch can be used to retrieve data. Yes, but the browser is telling me no. You try to use fetch, but it has been blocked by some security policy. Bad story. Just because it's a protection. Is it here? No, I don't remember where we have in the slides, but we'll find it in the slide later. But this course policy is protecting me from the cross-origin attacks. Okay? The browser is putting an extra constraint so that a given application, which is running on this server, the application, JavaScript application is running on this browser. The JavaScript code was generated by this origin. Origin is just the server from which the JavaScript is coming. So the browser is running this code, it trusts this code, more or less, and it allows this code to do extra checks, extra calls, sorry, with a fetch. Basically, these extra calls should always go to the same origin where the JavaScript is coming from. So I visit a website, and that website can call back home, make calls to the same server, but it's blocked if it tries to do calls to another server. See it on the other way around. I am publishing an API server. I'm publishing the API. I want to control who is going to call my APIs at the network level, before authentication and stuff. So the API server, by default, or the browser enforce the policy that where the API server, by default, we should always receive calls from JavaScript code that has been delivered by the same API server. But now we have a JavaScript code, which is the React application, which has been delivered by another server. They are both localhost, but they are running on different ports, so they are different origins. So the browser is asking, basically, to the server, can we do this? And the server is telling no. Because the JavaScript, the origin of the JavaScript doing the fetch is not the same as the origin of the destination of the call. How to unblock that? Well, for unblocking that, we need to tell the server to accept those. And the easy way of doing that is just saying, well, we can accept everything. So that will be something that we need to modify on the server, so that we can see the first API run before the break. So we need to modify the server. And there's a module called course in Express. So let's just see it here. Oh, there's a middleware which is called course that need to be installed, of course, and we can specify here which are the origins from which we are accepting calls from. And for now, just for implementing something in development mode, we can just accept from everybody. So enable all course requests. In a way, we are disabling this check. Okay? So this requires 3 lines. First, we must stop the server here. Then we must install npm install course. Okay, now we can restart the server. We can go to the code, we can import course from course. We are in the server, right? And then in the middleware, we app.use course with no arguments. If we want to set a specific policy, we can customize it here with the arguments, of course. There are some examples, say, okay, which are the origins I'm accepting the calls from, and so on. But like this, we are just opening, which is not, of course, a good solution for production websites, but in development mode, we can work with that. So right now, when we save this, the server should now accept all the calls, and let's see if it's true from the client side. Where is that? My application. So let's try to go back. Yep. What I'm seeing here is, let me do it again. So let me reload the application and see what happened. Okay, this is the main page. We are loading a lot of stuff. When I click on the login, that will redirect me to the home view. Well, actually, it already happened. It already happened here. Because the question has not displayed yet, because the component is not rendered yet, but they're already being loaded because they've been loaded in app. So you see that we have this fetch. This is the network panel, so all the network calls that the browser is doing. We have these network calls here. Let me make it larger. Where we called actually API questions with a get, and we had a response containing this JSON. So the client actually called the server, got the response in JSON format. We parsed the JSON, we copy it into the state. So if we go to the components and ask for app, we see that now we have a state here that contains the questions. And now this state, the story is done, because this state behaves like any other state in the application. It's been passed to a prop and it will render and so on. Okay? So that sort of closes the loop from a component that wants some data, activates an API call, and stores the results of this call into a state variable. This is all a side effect. Everything of this happens outside the React lifecycle. The only starting point is when this is started, at the component mount time, and how it ends with a set state. Everything else is totally outside the rules of React. Okay? We can control when to call this and how to use the result, and everything else is just outside the rules of the functional programming. This is the basic, the first step. Of course, there's still a lot of details. First of all, managing the errors, the exceptions, and so on, and the asynchronous behavior and so on, but it's something for the next hour, I would say. Okay? Okay, so with the knowledge that it's working, I will commit it right now. We can make this 15 or 20 minutes break, and then try to polish it and see the details that we are missing right now.